Hey, this is Sir Brian Orlasan Cordova. So, ito ay ang Mathematics in the Modern World. Chapter 1 is about mathematics in our world. Okay? So, the first topic is the patterns and numbers in nature and the world. Okay? Patterns in nature are visible regularities found in the natural world. So, ito yung mga nakikita nating patterns where yung mga patterns na yun ay pwede nating i-count, bilangin. Yung mga patterns na to ay pwedeng i-model mathematically. Meron tayong mga Greek philosophers na kung saan sila yung unang nag-aral ng mga patterns at kung paano gumagana ang ating mundo. Noong 19th century, meron tayong mga mathematicians kung saan kabilang si Joseph Plato. So he examined soap films leading him to formulate the concept of minimal surface. So yung soap films na to ay yung surfaces ng mga bula kung saan pag nagsama-sama sila ay nagkakaroon ng patterns or shapes yung kanyang surface. Okay? Si Ernst Haeckel naman, he painted hundreds of marine organisms to emphasize their symmetry. For example, yung mga starfish, mga shapes ng mga shells, yung mga formation ng shell ng turtles, yung mga seaweeds, etc. Si Darcy Thompson, pinag-aralan niya yung growth patterns ng mga hayop at halaman kung saan pwede nating i-prove yung kanilang paglaki by simple equations. So nakikita natin that yung shapes ng bawat isda and even yung skull ng humans ay pwedeng i-graph, and when we stretch yung mismong graph ay nagbabago din yung patterns or growth ng bawat species ng isda. Okay? So even the Nautilus shell ay nagpa-follow dun sa ating tatawag na golden spiral. In 20th century, so last century, si Alan Turing, so he predicted that there will be a mechanism for morphogenesis, or ito yung development of tissues ng organisms, which gives rise to patterns and spots and stripes. Example are those what we call the Turing pattern. So yung mga cell tissues ng iba't ibang organisms. So meron tayong iba't ibang patterns na pakagaya ng mga spots and stripes sa iba't ibang hayop. Si Aristide Meyer and Benoit Mandelbrot naman ay pinakita na ang math of fractals ay pwedeng i-create yung growth patterns ng mga halaman. Example niyan is yung tinatawag nating trees and yung patterns nung pagkakaroon ng mga sanga-sanga ng mga halaman. Ito naman yung tinatawag nating Mandelbrot fractals. Kita natin na yung patterns ay continuous lang hanggang tayo ay nagzo-zoom. Next. So, ano ba yung mga patterns na nakita natin sa nature? Okay, example niyan is yung snowflakes. So, yung snowflakes is actually an example of fractals because yung patterns niya on all sides ay paulit-ulit lang, or pwedeng pare-parehas yung itsura niya in all sides. Honeycomb. So, ito yung sa minimal surface. Every cell ng bahay ng mga bubuyog ay in the shape of hexagon. Next is sunflower. Okay. So, yung petals niya ay is actually example ng radial or fractal pattern. And kung titignan natin yung gitna or yung arrangement ng seeds, ito ay merong spiral pattern. Tiger stripes, so example ng stripes. And there are patterns na inadapt para sa landscape ni W. Gary Smith. The first example niyan is spiral, radial, scattered, dendritic, fractured, mosaic, serpentine, and naturalistic drift. Okay, so the example of spiral. So, makikita natin dun sa ating pattern ay paikot-ikot yung in-arrange niya yung mga bagging. Okay. Next is radial. So, itsura ng mga kalsada is nagpo-protrude mula sa gitna papalabas. And meron tayong mga circular pattern ng roads. Okay. Paikot dun sa center. Scattered. Ito naman yung mga mukhang ikinalat lang pero kasama na dun sa design para maging mukhang maganda yung landscape. Dendritic. So, ito yung parang ugat lang. So, example niyan is yung mga pinagdaanan ng mga tubig where nagkakaroon tayo ng iba't ibang sanga ng ilog. Fractured. Ito naman yung mga patterns na parang basag lang. Okay, kagaya ng mga bato, rock formations. Mosaic. So, ito yung mga patterns na nagkakaroon ng iba pang shapes or image by combining different patches of stones, pieces of rocks, etc. And serpentine is yung parang dinaanan lang ng ahas. So, kung makita natin dito, yung bagging ay inayos niya into a serpentine pattern na yung bagging na yan is actually in the night ay meron ilaw. So, landscape design siya na parang natural lang. The naturalistic drift is actually yung natural na pag-usbong ng mga halaman. Kung saan mo sila itananim ay hahayaan mo na kung paano silang tumubo. Sample of numbers in nature. So, in nature, meron tayong mga patterns na pwede nating i-count. Example niyan is yung dahon ng clover or ng tatawag nating shamrock, the symbol of St. Patrick and the Celtics. So, there are three-leaf clover. Insects, octopus. Octopus, sa pangalanan nila, octo means 8. That is 8 tentacles. And yung kamay ng tao, there is always 5. Normal sa atin magkaroon ng 5 fingers in one hand. Next is the Fibonacci sequence. Fibonacci sequence ay dinevelop ni Leonardo Pisano Bogoglio. He lived between 1170 and 1250 in Italy. So, he's an Italian. So, yung nickname niya is actually Fibonacci, roughly meaning son of Bonacci. So, yung tatay niya ang mas kilala. The famous for Fibonacci sequence, and he also helped spread Hindu-Arabic numerals and Roman numerals in the world. So, ano ba yung rule for the Fibonacci sequence? So, yung Fibonacci sequence is actually yung susunod na number is actually sum ng naunang dalawa. Okay? Where your x sub n o yung term na hinahanap mo, okay, is yung sum ng x sub n minus 1 which is equal to sa first term na meron ka or yung unang number na unang gagamitin mo. Then yung x sub n minus 2 is actually pangalawang number na gagamitin mo. So, ito yun. Now, for example, given a table, yung x sub n is your kung pang ilang term yung number na meron ka. And the Fibonacci sequence is starting from 0 or 1. So, x sub 0 is 0. And then x sub 1 and x sub 2 is both 1. Okay. Then x sub 3 is the sum of yung unang dalawa. So, we have 1 plus 1 is equal to 2. Then yung x sub 4 is actually sum ng 1 and 2, which is 3. X sub 5 is equal to 5. Sum siya ng x sub 3 and x sub 4, which is 2 and 3. And so on. Okay? So, next is 8, 13, and 21. Okay. So, paano ba natin makukuha yung mga next terms? For example, yung pang-siyam na term. So, to find x sub 9, so kukunin natin siya by adding x sub, yung n minus 1 natin, which is 9 minus 1, and n minus 2. So, we have 9 minus 2. So, ang pag-i-add natin is actually yung kasunod niya sa unahan na dalawang number. So, let's substitute yung value ng nasa Fibonacci sequence. Okay, so yung x sub 8 is actually 21 and yung x sub 7 is 13. So, we have 21 plus 13. So, yung x sub 9 natin is 34. Okay, for general nth term, finding the nth term, so kahit pang ilan pa yan, so let n be a positive integer, or ito yung pang nth term natin. Let yung alpha is equal to 1 plus square root of 5 over 2, and beta is equal to 1 minus square root of 5 over 2. And yung formula to find the nth Fibonacci number, f sub n, is given by this equation. So, f sub n is equal to 1 over square root of 5 times alpha raised to n minus beta raised to n. So, ito is actually binomial expansion. Okay. So, for example, what is the 10th term of the Fibonacci sequence? So, our solution would be, so yung ang hinahap natin ay yung pang-10. So, let n is equal to 10. So, yung f sub n natin would be, okay, formula natin. So, kung isa-substitute natin yung alpha, which is 1 plus square root of 5 over 2, and yung n natin is 10, so kung pang ilang hinahanap natin number, minus yung beta raised to 10. So, we can expand this by using calculators. We can just find the answer. Okay. So, ang ginawa ko dito is, nilabas ko na yung denominator 2 raised to 10. Okay. Para ma-simplify natin. In-expand natin ito. So, we have this expression. Then, removing the groupings. Okay. So, we have minus 62,976. Then, magiging addition nito. We can cancel yung positive and negative 62,976. Okay, so meron na tayong combine similar terms again, 56,320 square root of 5. Then yung square root of 5 dito is pwede natin i-cancel dito sa denominator. Then, by simplifying, we have f sub 10 is equal to 55. So, checking natin is since given na yung ating f sub 8, which is 21, and na-solve natin kanina yung f sub 9, which is 34, we can just add them to find the 10th Fibonacci number. So, this is applicable for all terms ng Fibonacci sequence, kahit hindi given yung previous two. Okay? And the golden ratio. The ratio of any two successive Fibonacci number referred to as n represented. So, yung golden ratio ay may symbol na phi, which is equal to roughly, approximately 1.618034. So, it is a continuous non-repeating digit. So, by definition, ito yung ratio ng dalawang magkasunod na number sa Fibonacci sequence. So, B is your second number and your A is the first number. Okay. So example, so yung 5 and 3. Okay, so yung mas malaking number is nasa numerator and yung smaller is nasa denominator. So 5 over 3 is approximately 1.66667. So continuous yan, rounded off lang. Next is yung pair ng 8 and 5 is equal to 1.6. And 13 over 8, 1.625. So as we use larger numbers, mas lalapit tayo dun sa value ng P itself. Okay? The golden spiral also follows yung rule ng ating golden ratio, or it follows the pattern ng ating Fibonacci sequence. So spiral coming from is 1, next number is 1 again, 2, so ito yung number ng ating Fibonacci sequence, papalaki na papalaki na papalaki. So yung spiral natin is what we call the golden spiral. There are regularities in the world as organized by mathematics. So the first is the motion of astronomical heavenly bodies. So yung paggalaw ng mga araw, buwan. So fixed na yung takbo ng araw, di ba? So sumisikat siya sa east and lumulubog sa west. So fixed yun, and it is organized by mathematics. The arrangement of colors in the rainbow, so fixed na siya. Hindi siya magbabago. It is Roy G. Biv yung pattern. Never na mag-jumble yung color na yun. The reflection in the mirror, diba? So kung ano yung image na i-reflect niya, so yun yung makikita natin. Wing patterns of the butterfly. So lagi siyang symmetric. Kung ano yung pattern doon sa left wing, ganun din yung sa right. These things are naturally occurring. So fixed siya. So, and never changing. They follow some rules that can be interpreted in a mathematical sense. Next is phenomena in the world as predicted by mathematics. So yung mga bagay na mayroon patterns can be predicted. Like example, weather and climate. So meron tayong tinatawag na seasons. So every year ay nagfa-follow tayo dun sa pattern na yon. And yung sa weather natin, kung ano yung trajectory ng bagyo ay hindi magbabago agad-agad. Okay. Next is exchange rates. So pwede natin i-predict yan because of the global economic factors. And inflation, same with exchange rates, ay affected ng economics. There are things in the world which follow certain rules. We can gather data from the changes made by this and predict what will happen using data. And there are occurrences in the world that can be controlled by mathematics. Example is the life expectancy of living organisms. So nakakontrol natin siya by taking medicines. Okay. Motion of objects. So example niya is in physics. Income and expenses. So we can control our income and expenses based from what we can do. Okay. If things can be predicted, then we can also manipulate their outcomes. We can calculate the changes needed to have the desired outcomes.